On this question, we want to evaluate f over g of 0, given that f of x is equal to square root of x plus 1, and g of x is equal to x squared minus 3. So there are two basic approaches to solving this kind of problem. We want to find f over g of 0. So the first approach to finding f over g of 0 would be to first build the function that it's talking about here. We weren't given the function f over g, so we would first build that function. And in the name of the function, there are instructions on how to build it. F over g of x is the function called f divided by the function called g. And we were given those individual functions of f and g. So we can build this function to be square root of x plus 1 over x squared minus 3. So we have f over g of x being square root of x plus 1 over x squared minus 3. Once we've built that function, then we'll evaluate. So we're going to find f over g of 0, and that means substituting a 0 in for x for this function. So we have square root of 0 plus 1 over 0 squared minus 3. That's square root of 1 over negative 3. Square root of 1 is 1. 1 over negative 3 is negative 1/3. So we've evaluated that function and gotten negative 1/3. So that's one approach. Another approach to solving this problem is to start off with f over g of 0, and if we follow the symbols, follow the meaning of what we see here, this function is f divided by g. So if we do f of 0 divided by g of 0, we're going to be able to get this evaluation. So f of 0 means substitute a 0 in for f. It would be 0 square root of 0 plus 1. And then in the denominator we have g of 0. That means to substitute a 0 into the function called g. That's 0 squared minus 3, and we're going to divide those two. That's why I've put them into the fraction. So we have square root of 1 in the numerator, and in the denominator negative 3. Square root of 1 is 1. 1 over negative 3 is negative 1/3. So you can see either way we've gotten the same answer. For this question, we want to first rewrite the quadratic function in vertex form by completing the square. Then complete parts A through C. And parts A through C are to find the vertex, the orientation of the parabola, and then the axis of symmetry. So our function is f of x equals 2x squared plus 4x minus 5. And we want to rewrite the quadratic with completing the square. So when you're rewriting with completing the square, you want to factor out the coefficient of the x squared term, but only factor it out of the first two terms, the x terms. So we're going to start by factoring out a 2. I factor out a 2 from the first term, and I'll be left with x squared. If I factor out a 2 of the next term, I'll be left with 2x. And I'm only factoring that 2 out of those first two terms, those two x terms. And I'm going to carry down that minus 5. Now I'm going to rewrite this to leave some space for the completing the square process. So I'm leaving a space to add a number to that group of terms, the x squared and the x term. And the number that we're going to add is going to cause that to be a trinomial, which factors, and it factors in a very specific way called a perfect square. So we need to come up with the number that will make that work, and I typically call it the magic number. And you can find the magic number by starting with the coefficient of the x term. So this is the only part that's different from, if your problem is different from mine, you will have a different number there. But the rest of it will be the same. So you start with that number, and then you divide it by 2, and then you square it. 2 divided by 2 is 1, 1 squared is 1. So for this example, the magic number is 1. So I want to put that number right here. But I'm not allowed with equations to put in any number I want, because if I put a number in, then that's going to change the value of the function, and it's no longer equivalent. So notice we have an equal sign right here to indicate that it is equal or equivalent. If I go throwing in a number, that's not equivalent anymore. So in order for me to put a number there, I've got to balance the equation. And the way that we balance in this case is by adding and subtracting the same amount. So if you add 5 and then subtract 5, that's 0, and adding 0 doesn't change the value of the function. So what causes this to be even a little bit trickier than that is the fact that we're putting the number inside of these parentheses. Because we're putting it inside the parentheses, this 2 has an effect on that position. So not only do we have to balance, but we have to consider balancing with that 2 there. So we know the number that we want to write is a 1. We're going to put a plus 1. And now we have to do the balancing, taking into consideration that 2 in front. So if I think about the distributive property, that would be 2 times the 1 that I just wrote in there. So essentially, I have added 2 to the function by writing that plus 1. So then I'm going to do the opposite over here. So I'm going to subtract 2 over here to balance out that plus 2 that I've put. So let me rewrite it because I have it a little bit messy. That's 2 times x squared plus 2x plus 1 minus 5 minus 2. So now we've rewritten the equation with that magic number. Inside the parentheses, this will factor, and it's going to factor to be x and x with a 1 and 1, both pluses. On the outside here, minus 5 and minus 2 is minus 7. And notice that the x plus 1 and the x plus 1 are the same, so we can write that as x plus 1 squared. And now we've rewritten that quadratic function from general form into vertex form. We have 2 times x plus 1 squared minus 7. So now that we've got it rewritten, we will take a look at parts A through C. We're looking to find the vertex, the orientation, and the axis of symmetry. And in order to know the vertex, we need to know that this quadratic equation is now in the standard or vertex form. So the vertex form is if we have f of x equals a times x minus h squared plus k, and this h and k are the coordinates of the vertex. So for our example, we have a plus 1 and a minus 7, So that means that our vertex is -1, -7. You'll notice that in the vertex form or standard form, we have a minus sign here, but in our equation, we have a plus. So if it will make you feel a little bit more comfortable with that vertex, I can rewrite this. Every addition can be written as a subtraction. You can write it as x minus a -1 squared minus 7. And so now that matches our vertex form a little bit better, and hopefully you can see why our x-coordinate is a -1. So it's the number after the minus sign that will give us that x-coordinate of the vertex. So we have a vertex of -1, -7. We want to find the orientation of our parabola, and the orientation is either going to be a parabola that opens up or a parabola that opens down. And we can tell the orientation from this value of 2, or A, in our vertex form. Anytime the value of A is greater than 0, we have a parabola that opens up, and anytime that A is less than 0, we have a parabola that opens down. So in this example, since A is 2, that's a positive value, we have a parabola that opens up. And then finally, we have the axis of symmetry. And with a parabola, you have something that is symmetric. That's why it's axis of symmetry. And if we take a vertical line and pass it through the vertex, you can see on either side of that vertex, you have a mirror image. So our axis of symmetry is going to be a vertical line that passes through the vertex. So I'm going to use the x-coordinate of the vertex to indicate that the axis of symmetry is the vertical line x equals -1. Thank you for checking out my videos. Have a great day.